Sophia Dagnello is the Senior Visual Information Specialist working here at NRAO. She works with the EPO office, our department, translating complex radio astronomy data and science into public outreach visuals. That's a very short way of describing an awful lot of really impressive work. So I'm going to let Sophia take over now. Welcome.
Awesome. Thank you so much for the introduction and setting this up. So yeah, I'll be talking about kind of how we're using scientific visualization to explore and communicate radio astronomy, specifically in the public education and outreach sector of NRAO. So brief overview of what I'm going to be going over, kind of what is scientific or radio visualization, and then how we use radio astronomy visualization here at NRAO, specifically in EPO, and then the different types of astronomy visualizations that we do, looking at data, kind of artist impressions, and so on and so forth. All right, so what is astronomy visualization? At its most basic, it's utilizing different types of visual media to effectively communicate complex science to a specific audience. Obviously, in my case, we are focusing on more of the public, but it applies just as much to the scientific community as well. So why is this important? Using visual media to communicate science taps into one of the key ways that humans process information, which is visually. It's a really good way to take something that can be very complicated to read or try and understand in that method and show it in a visual way that allows people to kind of grasp the information and comprehend it and retain it a little bit more. So this allows for better dissemination of information as well as information retention, especially when targeted towards a specific audience. It also increases the interest and engagement that a viewer has with this information. If it's done correctly, that is the goal. And using astronomy visualization well can benefit not only people like me who work for the public outreach communication sector, but also the science communication as well when you're looking at papers or research presentations. All right, so kind of diving into how we do this, I've boiled it down for me. I use something called visual storytelling. So visual storytelling is essentially how we tell a story using a visual that can stand on its own or a visual that works in conjunction with text or dialogue. So like a animation or in conjunction with press releases, we use images with their narration to create a visual story. So it's important that we tell a clear and compelling story that engages, informs, and inspires without being misleading or unclear to the audience that we're talking to. A classic example of this is if you're looking at radio astronomy data, one of the more popular things that we see is in the science community is using red and blue to represent different things. But in particular, red and blue have very specific connotations to the public. So if we use those, like hot and cold would be the example. So if we use those to represent things that weren't hot or cold or opposite, they were cold or hot, using blue as cold or blue as hot and red as cold, that would be very confusing to our audience. So always making sure that when you're telling your visual story that it is appropriate for the audience that you're communicating to. So I like to use this pyramid to kind of explain how visual storytelling disseminates and kind of to different audiences and their kind of background. So if we are looking at the little triangle on the right, you'll see at the bottom, it starts with the proficient. So this is going to be the scientists and content experts, like many of the amazing colleagues that we have here at NRAO. They are the content experts. They have the background, the knowledge, they went to school for it, they deep dive. Next up in the middle, you're going to get like the engaged and curious, who are people who have spent a lot of time looking into it and are already invested in learning more, but maybe don't have the same kind of research or experience that our proficient group would have. And then the biggest group is going to be the general public. So these are the people who don't have a lot of knowledge and don't interact with the information at a high frequency. And they're always the kind of group, because it is the largest, especially in EPO, that we want to kind of target. All right, so on the left side, we have what we are communicating to those audiences that are on the right. So starting at the bottom, we have like the expertise. So this is the foundation of what we are trying to communicate, the topic that is made of, details and facts. So like research, scholarly data. And as we move up through content, and then what is most important to the general public is creating this context. So while you can give them the information and provide the basic facts and details without creating the what it is and why it matters, the context behind that information is what makes it really be absorbed, embraced, and like engaged with the general public. So at EPO, our goal is to kind of move our way up through that pyramid that's on the left, so we can provide that context in the type of storytelling that we're able to do for radio astronomy. All right, so in my job here as a kind of visual communicator, what we do for most of our products is that we create a narrative story and then a visual representation of that narrative story. So using the narrative story is kind of an organizing tool for our memory that, is able to activate a, associative sense and emotional response that allows the, reader to have better recall, kind of reasoning and like motivation to engage with and understand that content. And then obviously the visual representation side of it is an effective way for our brains to take in information, kind of process it, and if designed well, they can actually, it increases retention as well. So combined together, that tends to be what the type of products that we produce in EPO. A good example is kind of like press releases. We have our awesome EPO public officers, press officers that create the narrative story about a press release and science research. And then we, like my team that I work with, creates the visual representation that goes along with that narrative story. So now that we know kind of the basics of like visual storytelling and what astronomy visualization or scientific visualization is, I'll talk a bit about what we do with astronomy visualization in EPO specifically. So in EPO, we want the general public to understand what we're doing and what the significance is. So that's why we use what I had previously mentioned, the narrative story along with the visual representations. So a couple, areas that we work on pretty often is going to be press release support, education materials, and kind of general outreach materials. All right, here's the awesome kind of smaller flow chart of EPO. We have our press officers who deal with obviously the press and STEM education, and then where I am over here in the multi-media group. And working together collaboratively between all three of these is how we come up with most of our visual products, and is like the dissemination point for all of these as well. All right, so I'll give a kind of an example of a project that we work on and how our workflow works here at EPO. So when we get a press release in, it goes, the scientist who did the research or principal investigator will directly contact our press release officers like Amy Oliver or Dave Finley, and then they will decide if they're going to move forward with that. And once that all is approved, that's when the visual support kind of comes in, and we work with the press officers as well as the principal investigators or scientists to develop visuals that assist in the story of the story that they're telling of the research. So it kind of, we do a lot of back and forth with our PIs, trying to make the graphics as accurate as possible, but also as like clear and understandable to the public who the press release is actually, the audience for the press release is. So over on the side, you can see some data images that were created for a Vertigo press release. And these are kind of just exclusively radio astronomy data images. Because the data images are so nice, we didn't actually have to create additional graphics to go alongside those, like artist impressions. So I'll get into kind of the fun, pretty pictures of what we do. So when we're talking about astronomy visualizations, they can kind of be broken down into different categories. One of them being the data or scientific visuals. And that's going to utilize data from our different observatories, not just radio. Sometimes we do composites with optical or infrared. And then we also have another category of visuals, and that's going to be artist impressions. So when we're talking about a certain astronomical event or object that maybe we don't have a great data image of, it's important for us to create a artistic rendition to better kind of show what that research or science is trying to explain. And these are, you know, based off of data, but not necessarily like real, if that makes sense. And the third thing I'll touch on a little bit is, you know, some of the newer things that we've been working on, which is like virtual reality and kind of interactives with mixed reality and like augmented reality and different types of interactive content in that sense. So I'll do a quick example of a project that we worked on a couple years ago, showing Europa. So this is a near infrared image of Europa. You can see there's lots of detail and information there. It looks very nice. Thank you, NASA's Galileo. And the goal was to create a image with the radio image of Europa. So this is the radio image. As you can see, it's a little bit less impressive, which is fairly common in radio astronomy data, but our goal is to kind of communicate as much about that data and make it as engaging as possible for kind of the public audience that we're looking at. So I'll kind of go through a bit of the processing that we do with these images. All right. So the first step that we take from kind of getting the original FITS files from a scientist is we do additional image processing. So they import the FITS files into FITS Liberator, which is a really easy to use kind of image processing software that's developed by NOAA Lab and was designed specifically for astronomy visualization. And we utilize it to kind of take the raw observations and then create kind of color images. And it works with FITS files, which obviously most people are familiar with here, but in case you're not, it's how astronomy data comes in, and it's, you know, before we turn it into an image. So kind of the important pieces here are, and things that we look at are the scaling or the dynamic range of the image. So this scaling function allows us to work with and kind of utilize the dynamic range of the astronomy image as best as possible. Many astronomy images do have a very high dynamic range, which means that the data values from the faintest part of the image to the brightest part can be factors of 1,000 or even 10,000. And we want to be able to kind of show the breadth of that range in an image, in our final image. A very common example of this would be like, you see it a lot more in like high dynamic range photography, where they use either a very like fancy camera that allows to capture it, or a series of images that preserve all of the visual data in the photograph. And that's what we want to do in the astronomy images. We want to preserve all of that information that we get. All right. So once we have a scaling that we like and is approved by kind of like the PI, We then move into adding color or false color. So obviously that image does not naturally have any coloration to it. So the next step is that we add in a color map. And these color maps are typically, I do them in Photoshop, but if you're a scientist, you obviously are familiar with all the other ways that those can be added. And they essentially overlay color onto the grayscale image and go along with the kind of dynamic range of that astronomy image. I have a few examples of color maps over to the right, and these are called like perceptually uniform color maps, which is the type that I prefer to use and then also create depending on the image. So these are fairly basic ones that are used quite often, but you can also create, your own versions of these. And what perceptually uniform means is that they're designed in a way that the amount of like the incremental change in lightness and saturation of the color map is uniform throughout. So if you had something that was, say, not uniform perceptually, you can actually get areas of like blowout where you lose detail and information from the image itself. So by utilizing more of these like perceptually uniform color maps, that allows us to retain all of the information and keep the images as accurate as possible. Most of what we do, what we do with these, I do in Photoshop, but there's like quite a few good free ones. I think GIMP is the most popular that you can utilize similar methods to add in these color maps. Yeah, so once we've taken a bunch of different options for color maps and kind of gone through them and talked about, talked with the PI, looked at kind of what we were looking at design wise, we can decide on a color. So we went with the one that's over there on the right. It happened to fit the graphic design and also show the detail that we wanted in the image. So we ended up moving forward with that image. All right, so now that we took the final image, the last and somewhat, I would say almost most important step is providing the context to this image. So this was part of a series of poster designs that the multimedia group worked on. And I'll do a shout out to Jeff Hellerman because he designs most of these and does a fantastic job. So we took the final image and we added design context, graphic elements, and then obviously the narrative. So adding something like the scaling to this is very important to provide kind of more information to the public about what this is. Obviously, we also added in the background as well, Jupiter, and then we, utilized some of the imagery of the telescopes that were used, ALMA was used to take this image. And then we also added the narrative section to this as well. And then all combined together, it creates a very well-rounded, very, comprehensive image and poster of Europa and the radio data that we use to create this image. All right, so moving on, I will talk about a artist impression kind of example. And so this was a gamma ray burst. And as you can see with the radio data, it doesn't really show any of the kind of very complex things that are happening in this kind of gamma ray burst event. So, and just a bit of background on this. We have a bunch of different components that, after talking with the principal investigator of this paper, they wanted to include. So we had a stellar explosion, a supernova, a black hole, jets, a forward and reverse shock happening. And so the goal was to come up with some illustrations and animation of this event. Obviously, you can't quite tell any of those things from this image. So coming up with a really comprehensive illustration and animation was very important for this. And so just kind of going through the process here. We started with the paper, obviously, and then had a quick discussion and multiple meetings, kind of sketching out a storyboard, which you can see here. And this is mostly explaining the timing, the general motion, the location of the jets, and the location of the forward and reverse shock that you're going to see. All of this is, multiple meetings to try and nail down what is actually happening in here and how we communicate that in a animation clearly. All right, so we got some final images, and this is kind of what we were kind of going for. It was a little bit more stylized version, not going to try and be super realistic like you would see in a kind of like Hubble image or something. Also, because most of this is obviously not visible and optical. So this explains kind of, we went through a couple draft images. There was some problems and like misinformation there, and we ended up settling on this as a final image in the bigger image up in the left, and then the final kind of press image ended up being actually the one in the bottom right corner. Sorry, top left, bottom right. So as you can see, you show the black hole is surrounded by its disk or sphere material, and then the jet, which is white, and then you see the forward shock on the far left, and then the reverse shock, which you can then see in the center of the jet, which is this little bit that's going down. Yeah, so that was a particularly fun one. We actually, after we finished this, we ended up doing some fun sonification of the data as well, because you could actually hear and the like reverse shock and the forward shock as well. And that was quite exciting. And something new that I hadn't really experienced before or seen was the sonification of radio data. Definitely like a plus as far as when you're looking forward towards accessibility and everything. Visuals aren't going to be the only, hopefully, feather in the cap for how we can show different ways of radio astronomy data. Okay. So I will talk about the virtual reality kind of stuff that we're doing here at NRAO. And the virtual reality tours were started a few years ago, right before COVID, and we created some, if you went to the AAS in Hawaii for 2018, 2019, or 2020, I can't quite remember, it's been a while. We created a VR kind of landscape of the NGVLA, and this was to show and have people be able to experience walking around within the array, obviously in virtual reality, and having that at our booth at AAS was quite exciting, and it kind of launched the virtual reality projects that we've been working on the last couple of years. So one of the big ones is this tour of the VLA and NGVLA that we put together for NSF staff a year and a half ago. So what we did here was we actually partnered and contracted with a virtual reality platform called Engage, and they have a system and a software that's in place that allows different people to join in virtual reality as avatars. So you can see some of these here, and you can see different people kind of wandering around on the site. And when we were partnering with Engage, we kind of did a two-prong approach and looked at not only kind of building our own scenes in virtual reality. So that would be like what you see in the upper left-hand corner is actually the NGVLA array from the balcony out at the VLA site. So this was all built in 3D and is fully immersive virtual kind of experience that we were creating. We also had the second part where we wanted to record at the VLA site itself in 360. So we utilized a 360 recording camera and actually recorded all the different locations that you see in these other images. So one is down in the barn, near the transporter in the bottom left-hand corner. The dish surface itself of one of the BLA dish is up in the upper right-hand corner, and you can see another version of that down there. Part of the originally the plan was to record live and have live speakers at each of these 360 recording sites. And there was always, every project has a problem, and the problem was bandwidth there. So we switched to actually pre-recording everything, and we had different speakers at each of these locations, kind of giving a 3 to 5 minute talk on their different expertise. And so we obviously had one on the dish surface, somebody in the barn, and then we also had a control room expert as well. This went over very well. We finally compiled it all into a full presentation and worked with NSF to set up a series of meetings with them to go through and show kind of the capabilities of this program, as well as really highlight all of the amazing people and technology that we have at the VLA, as well as the new and exciting potential for NGVLA. And then, now moving forward, we're hoping to create a VR experience that is not just focused towards the VIP kind of NSF staff that we were working with, but something that is accessible for the education side of EPO as well. And, expanding it to include the new design for the NGVLA telescope, as well as kind of a experience showing the path of light as it's collected by a radio astronomy telescope. And that's a more general kind of just public audience experience that we are actually currently developing. Yeah. I ended a little early. I hope that's okay for everybody. But I noticed there's lots of questions, so I would love to start on some of those.
Thanks, Sophia. Let's see, I'm just looking through here. I see a lot of really great comments, which I'm sure we'll want to save so that you can see them. But I'm not seeing any questions. So maybe if people could just raise their hand if you have questions, or put it in the comments section now, the chat section now, and we'll keep an eye out.
We have our first raised hand with Adam. Go ahead, Adam.
All right, thanks. Great presentation, Sophia. I have a question about the tools and the methods and how applicable they are to other fields. So how much of this is just for astronomy or best tailored for astronomy? And how much of this would be applicable, for example, if you were to tell the story about climate change or some other?
Yeah, so for obviously the specifics when it comes to the data kind of processing, that's obviously very astronomy specific, but the concept of visual storytelling and scientific visualization is applicable across, I would say, almost all fields of science. My background is actually originally in biomedical visualization, and that's what I did during my master's, as well as, the first few years after I finished that, I worked freelance in the bio and biomedical fields, doing a lot of this type of work, either focused towards, patient education, as well as kind of, general public, like promotional material that you would see from, say, like a pharmaceutical company. Yeah, so it is pretty much applicable across all fields. It kind of, you just tailor what you need to know depending on the audience that you are trying to target, if that makes sense.
Great, great. We also have another raised hand with Adele. Go ahead, Adele.
Thanks, Sophia, for sharing with us. You showed us some concepts that are obviously pretty complicated. I mean, gamma ray burst jets, reverse shocks, and you spoke about them very confidently. I trust that your representations are scientifically accurate. So I'm wondering, how do you go about learning the things that you need to know behind these images, and how can the astronomer who, wrote the paper also help that process?
Yeah, when I first started working at NRAO, I actually hadn't really had a lot of experience with astronomy. I'll be honest, my most astronomy experience was Astronomy on Tap in Chicago. So I was pretty much a newbie when it came to talking about astronomy concepts. But, to answer your question, like, I spend a lot of time personally reading the paper and trying to make sure I have a very strong foundation in kind of what we're discussing. That way, and doing, background research on concepts that I'm not familiar with. That way I can, I have a better idea moving into the conversation about what we are discussing. But on the sciences side, I think being able to sit down and spend the time, if you're looking at especially like a complex animation or illustration or a series of illustrations, sitting down, having a conversation one-on-one with whoever's creating those graphics with you, and kind of going through things in a way that maybe isn't the first thing that comes to your mind. So you want to think about it in a visual sense. It's like there's a lot of information in the science and in the papers that you will never be able to show visually. So you really do want to kind of, if you're talking about a gamma ray burst, like what are the pieces that need to be seen in that illustration? Like what's the important story that's being told? And how, and on the science, as a scientist, always being open to trying to describe something in a visual way, if possible. I know it's very difficult sometimes because we may not know what it looks like. But yeah, I'm okay with, the best guess is also a very acceptable answer. And it is a process. It's just making sure you're open to a little bit back and forth.
Thank you.
All right, we have another raised hand. Bong, if you want to go ahead.
Oh, hi, Sophia. Thanks for a nice talk. I have two quick parts in my question. The first one is what tool you use to make those graphic. AutoCAD gives you a free CAD, 3D CAD, right? But like the black hole you have there, is that you use Illustrator or something?
Yeah, so a variety of tools. So for 3D animations, we at EPO tend to use either Autodesk Maya, as well as I use Cinema 4D. There are free versions. I will utilize Blender on a regular basis. They've done some phenomenal advances in the last few years. So it's almost, I would say, almost on par with some of the very expensive paid for softwares. And then for illustrations, I use everything from Photoshop to Illustrator. If we're looking for something more vector-based, Illustrator is the way to go. And then, for videos, we do a lot of work in Adobe After Effects and Premiere. There's a lot of, post-production, especially in animations, that gets done in After Effects.
Awesome. So my second part of the question is, I think you partially answered it in the previous question, is as a scientist or engineer, right, is we always think critically and technically. So what tips you will give us to learn better to communicate complex concept?
Yeah, well, it's a hard one sometimes. My best advice that I can give is always consider who you're talking, like the audience that you're speaking to. If you're talking to other scientists, you can go into the jargon, but I would say like even really, really like well-interested people may not have the same kind of background as far as just the verbiage that's being used. And being able to kind of adjust how you're presenting the information. You don't actually have to adjust the information sometimes. It's just the way that it's being presented and the words that are being used is a really great way to kind of make things more comprehensible to people who may not have the exact same background and expertise that you have. That would be my suggestion for that. Some of my coworkers that do more of the narrative storytelling probably have much broader information they can give you on that side. But the visuals, it's just always try and highlight the aspect that you're trying to the most important thing that you're trying to show or explain in your research. That should always be kind of the most important part of the image. And then there's some graphic design principles that you can use to balance everything out. Adding context is another really good one, whether that happens to be scale or, that type of work.
Awesome, thanks.
And Amy, did you have something to add to that?
I do actually. So I was hoping we can. So for those on here who don't know me, so I'm Amy Oliver, and I'm the Public Information and News Manager. I work with Sophia a lot today. She showed a lot of my images that she's worked with me on for press releases for ALMA, and so I'm hoping we can talk a little bit more about the ways in which we work together to the benefit of scientists. So I've heard some questions today about how do scientists work with you as an artist to get to these beautiful images. And so I'll just say first, and then sort of let you keep going on this, that we actually start with what's called a press release questionnaire. So if you're working on ALMA, you come to me. If you're working on the VLA or VLBA, you would go to Dave Finley. If you're working on, if you're using Green Bank, you would go to Jill Molesky. So you come to one of us and start that process with a press release questionnaire, and we do that exact thing that Sophia was just talking about helping you figure out what is the most important thing it is you need to say and how to make it digestible. So we ask really particular questions to get you to that place so that we can help you talk to a different and broader audience. And then Sophia comes in, and now I'm going to be quiet.
Yeah, and then we kind of, Amy gets like a wish list from the scientists or principal investigators that she's working with on the press release, and then we basically have a sit down and conversation to try and get to what type of visuals we can produce to support this press release, whether that be an animation, illustration, data, images, any of those. We even do some augmented reality models sometimes, which are fun. And a lot of that is kind of, dependent on timeline of the press release and, what the actual paper is on itself. And and then we kind of go back and forth, develop graphics, and then when they're ready, we move forward with the approval process. And then Amy takes over again.
All right, Paul, you can go ahead.
And a quick question. You mentioned time, and I'm curious as to how much lead time you prefer to have from, so you're leading back on that one. Because I do a similar, basically the same rollout here at GBO, and sometimes we work on very, very tight schedules and things. So what's your optimal amount of time that you prefer to have to work on these things?
It depends.
Just so I can tell my scientists.
Yeah, it kind of
mind,
depends
Sophia?
on.
Do you mind?
Yeah,
so Paul, we want to know as soon as the paper has been submitted.
Yeah.
That's preferable.
Yeah, that is. Okay.
Yeah, we do get obviously kind of shorter deadlines on occasion, as well as, it is so dependent on like current workloads, like how many other things are going on, and what the product is. If it's an animation, it's gonna take at least a month, I would say, to get something really put together. And then illustrations and science images, depending on the complexity of them, can take much less time. yeah, but usually we stay in the realm of weeks, not days, as Susie put, as well said, to give everybody kind of some breathing room and allow for that kind of revision process to occur, because that ends up having the best result.
Okay. Well, did somebody did I hear a voice?
Yeah, this is Susie. I just wanted to add that one of the things that I think is so impressive is the very different digital products that the artists create, you know, from graphic design for things like posters that Sophia highlighted with the Europa one, to much more complicated things for press releases. I mean, it really does take weeks to do more than illustrations, but to add animations or the augmented reality, which I think is a really fun addition that Sophia brought to the team, because so many people experience so much content on their phones. The augmented reality is just so much fun to play with on your phone. If you're looking at the press release and you scroll down to the place where, oh my gosh, now I can have this triple star system, you know, hanging over my kid's head, or I can plant a VLA dish in my garden, you know, and then take a picture of it. It's something that not only gives the viewer an opportunity to interact with the visual, but it pays dividends back to NRAO, because then people can take that picture and post it on social media, and there's a whole different way of interacting with it that gives us a lot of bang for the effort that goes into creating the augmented reality simulations, and it gives the recipient of that just such different ways of interacting with the data. And the virtual reality is the next one, right, that we're excited to explore. So it's just very cool, from straightforward graphics and illustrations to bringing the data to life and having very different ways of exploring it. It's been really new for me, and I'm really excited by the talented artists that we have to do that. Just wanted to give that little endorsement. Not really a question. The other thing that I'll say about Sophia was this transition from medical illustration to the astronomical illustration has been really fun to see her grow over the years, and the way she's really embraced the tool. She did not know what a FITS file was when she started, and now and now she does wonders with them.
Thank you, Susie. I try.
Okay, I'll be quiet now.
Thank you very much, Sophia. This is just really fabulous. It's nice to sort of have a look behind all these beautiful images that we get to see on a regular basis. So thank you for taking the time to talk to us about it.